So the next derivation what you're having is related to the Joule's heating effect of electric current. We all know that formula H is equal to I square R T. H is equal to I square R T. Here H stands for heat energy, I stands for current, R stands for resistance, and T stands for time. So how we obtain this equation, we'll just see step by step. So the first step we are going to derive from the formula by using the potential difference. V is equal to W by Q. If I need, that means work done means I can rearrange the formula. W is equal to V into Q. Here Q is in division, while coming to the other side multiplication. Let's take this equation number 1. Now again from the Ohm's law formula, we all know Ohm's law is V is equal to I into R. Let's take this equation number 2, and then from current formula is I is equal to Q by T. If I need Q means the formula rearrange it as Q is equal to I into T. Let's take this equation number 3. So now what I am going to do means I am going to substitute the equation number 2 and 3 in 1. What is the equation number 2 over here? V is equal to I into R. Equation number 3, Q is equal to I into T. These two equations we are going to substitute in this place over here instead of V as well as instead of Q. So the W is equal to, instead of V we are going to substitute as I into R into, instead of Q we are going to substitute as I into T. Again work will be equal to I into I square R into T. So this work done we can also rearrange into energy. Why? Because work we can also write it as energy, because energy is defined as the ability or capacity to do the work. So energy is equal to I square R T. What type of energy it is? Heat energy. So H is equal to I square R T. Clear? And then, so you can say based upon the law, if you are going to say this equation means you can just write it as heat is directly proportional to square of current. Heat is directly proportional to the resistance of the conducting material. Heat is directly proportional to the time. Heat is directly proportional to the time. So by using this method you can derive the equation, and we are having one more method also is there. In order to derive the heating effect of electric current, we can just start by using the power relation. We all know power is equal to energy consumed by time taken. If I need energy means I can rearrange it as energy is equal to power into time. Let's take this equation number 1. Now we know that power is equal to V into I. Power is equal to V into I. Let's take this equation number 2. So now what we are going to do? We are going to substitute equation number 2 in equation number 1. So where you are going to substitute this over here means in the place of P we are going to substitute the second equation. So energy is equal to V into I into T. Even by using this equation also we can calculate the heat energy when potential difference, current and time is given. So you can just write it as H is equal to V I into Now, again, let's take this equation number 3 from Ohm's law. What is Ohm's law formula? V is equal to I into R. Let's take this equation number 4. So now again you are going to substitute equation number 4 in equation number 3. So energy is equal to, instead of V, we are going to substitute this value over there. So I into R into I into T. So I into I square. I into I square. So energy is equal to I square R into T. What type of energy it is? Heat energy. So therefore H is equal to I square RT. Which method is easier for you? We can go along with then either the first one or by using the second one. So the third equation is the right. So what is the third equation you obtained? H is equal to V I T. This formula we can also rearrange into other format. H is equal to V. We all know I is equal to Q by T. Therefore, Q is equal to I into T. So instead of this I into T, I can write it as Q. So this is another one formula what we'll be using in order to calculate the heat energy when potential difference and charge is given.